From mysterious cosmic giants that swallow light to the strange ways they bend time itself, black holes have puzzled scientists for generations. Today, we're diving deep into these fascinating space monsters to uncover their most surprising secrets. Let's explore how these cosmic giants come to be. When a massive star, at least 20 times bigger than our Sun, runs out of fuel, something amazing happens. The star's core can no longer support its own weight, and in just a few seconds it collapses inward with incredible force. This triggers a spectacular explosion called a supernova, lighting up its galaxy brighter than billions of stars combined. But here's where it gets really interesting. The leftover core keeps shrinking, packing so much mass into such a tiny space that nothing can escape its pull, not even light itself. That's the moment a black hole is born. Think of it like a cosmic vacuum cleaner that's gone into overdrive, creating a point of no return that astronomers call the event horizon. The event horizon is like a cosmic boundary line that makes black holes so special. Think of it as a one-way street in space. Once anything crosses this invisible border, there's no turning back. At this boundary, gravity becomes so strong that you'd need to travel faster than light to escape, which is impossible according to physics. The size of an event horizon depends on the black hole's mass. Bigger black holes have larger event horizons. For example, the black hole at the center of our Milky Way has an event horizon about 27 million kilometers across. That's like fitting 20,000 Earths side by side. What happens at this boundary is mind-bending. Time slows down dramatically, and space itself gets twisted in ways that challenge our understanding of reality. Now, let's talk about one of the strangest effects of black holes: spaghettification. Imagine you're an astronaut who accidentally gets too close to a black hole. As you fall in, the black hole's gravity becomes so strong that it stretches you like a piece of spaghetti. This happens because the gravity pulling on your feet is much stronger than the gravity pulling on your head. Your body gets stretched longer and thinner, like pulling taffy. The difference in gravitational force is so extreme that it would pull you apart atom by atom. For small black holes, this stretching happens quickly and violently. But for supermassive black holes, like the one at the center of our galaxy, you might actually survive crossing the event horizon before being stretched, though you still couldn't escape. This process isn't just limited to unfortunate astronauts. Stars and whole planets can get spaghettified too. Almost every galaxy we've found has a massive secret at its heart. A supermassive black hole millions or billions of times heavier than our Sun. These cosmic giants shape entire galaxies around them like cosmic architects. Take our own Milky Way's black hole, Sagittarius A, which weighs as much as 4 million suns. But here's the puzzle that keeps astronomers up at night. We're not sure exactly how these giants got so big. Some might have grown by eating lots of stars and gas, while others could have formed from smaller black holes combining. The biggest one we've found, TON 618, is a real monster. It's about 66 billion times heavier than our Sun. These supermassive black holes don't just sit there quietly. They create huge jets of energy and can make their entire galaxies glow when they feed on nearby stars and gas clouds. Black holes don't just warp space, they also play tricks with time itself, just as Einstein predicted. Near a black hole, time moves much slower than it does on Earth. If you could watch a clock falling into a black hole, it would appear to tick more and more slowly as it gets closer to the event horizon. From the perspective of someone falling in, time would seem normal, but to an outside observer, they would appear to freeze in time at the edge. This effect isn't science fiction. It's a real phenomenon called time dilation that we can measure. The stronger the gravity, the more dramatic this time warping becomes. A person orbiting close to a black hole might experience 1 hour, while their friends back on Earth live through many years. This strange relationship between gravity and time is part of Einstein's theory of relativity, which helps us understand how these cosmic giants bend the fabric of space and time. In the 1970s, Stephen Hawking made a groundbreaking discovery that changed how we think about black holes. They're not completely black after all. He showed that black holes actually leak tiny amounts of radiation, now called Hawking radiation. Here's how it works. Space isn't really empty, but full of pairs of particles that pop in and out of existence. When this happens near a black hole's edge, sometimes one particle falls in while its partner escapes. The escaping particle becomes real radiation, while the one that fell in makes the black hole slightly smaller. Over an incredibly long time, this process could make black holes completely disappear. For small black holes, this happens faster, but for big ones like the one in our galaxy, it would take longer than the current age of the universe to notice any change in size. In 2019, scientists achieved something incredible. They took the first ever photo of a black hole. This wasn't your typical snapshot. It required 8 radio telescopes across 4 continents working together like a giant Earth-sized camera. The target was a massive black hole in the galaxy M87, about 55 million light-years away. The image shows a glowing orange ring of hot gas surrounding a dark center, the black hole's shadow. Getting this picture was like trying to photograph an orange on the moon from Earth. The team collected so much data that they couldn't send it over the internet. They had to ship hard drives by plane. This photo proved Einstein's theories right and showed us exactly what these space giants look like. It took 2 years of complex computer work to turn all that data into the historic image we now know, giving us our first real look at one of space's most mysterious objects. When 2 black holes get close to each other, they create one of the most powerful shows in the universe. These cosmic pairs dance around each other in an orbital ballet that can last millions of years. As they spin closer together, they move faster and faster, like figure skaters pulling their arms in. When they finally merge, they release more energy in a few seconds than all the stars in the universe combined. This energy travels through space as ripples called gravitational waves, which scientists can detect using special instruments on Earth. These waves tell us the story of the collision, how big the black holes were, how fast they were spinning, and even which direction they were moving. The first detection of these waves in 2015 opened up a whole new way of studying the universe. You might think space is silent, but black holes have their own unique voice. NASA scientists recently discovered that black holes actually create sound waves. In 2003, they found that the black hole in the Perseus galaxy cluster was making deep sound waves, 57 octaves below middle C. That's way too low for human ears, but when scientists adjusted the pitch, they revealed an eerie cosmic note. These sound waves come from the black hole's interactions with the hot gas around it, creating pressure waves that ripple through space like sound through air. Think of it like a giant cosmic speaker where the black hole's movements push and pull the surrounding gas. The most amazing part? These sound waves help keep distant galaxies warm and play a key role in how galaxy clusters grow and change. Even with all we've learned about black holes, they still keep many secrets. Scientists are working hard to solve big questions like what happens at the very center of a black hole, where our current physics theories stop making sense. We're also trying to figure out if black holes could be doorways to other universes or times, though that's still in the realm of theory. Another mystery is whether tiny black holes left over from the Big Bang are floating through space. These primordial black holes might help explain dark matter, the invisible stuff that seems to hold galaxies together. New telescopes and tools are being built that will help us peek deeper into these space mysteries. And who knows? The answers might completely change how we understand the universe itself. Thanks for joining us on this incredible journey through the mysteries of black holes. If you enjoyed learning about these cosmic giants, don't forget to like, subscribe, and share this video. Stay curious, and we'll see you in our next space adventure.